Hello viewers, this is Wargada Ronald taking you through the story of A-level applied mathematics, and this video we're going to talk about the topic of dependent events or conditional probability. So this topic is still under probability theory and is suitable for students in both senior 5 and senior 6. So a probability is conditional if it depends on what has already occurred. Therefore, the probability that an event B happens given, so know this word is very vital in this topic. So given that an event A has already occurred is called a conditional probability of B given A. So what is here is what has already occurred, and what is here is what we want to get. So mathematically this will be written as probability of B slash A and is read as probability of B given A. So when you see this slash, it doesn't mean division, but it means a conditional probability of B given A has already occurred. Therefore, this probability of B given A can be worked out using the formula that probability of B given A is equal to probability of A intersection B over probability of A. So what you should realize is that numerator is the intersection of these two events A and B, and the denominator is what has already occurred. So probability of B given A has already occurred is probability of A intersection B over probability of A. So what has already occurred is what becomes the denominator, and the numerator is the intersection of both events. So whether you write B intersection A or A intersection B, everything is the same. So from there we also need to know something called Bayes' theorem. So Bayes' theorem is still under conditional probability, and how does it state? So remember, we can either write probability of B given A or A given B. So what if it is probability of A given B? So what you should remember is that the numerator is the intersection of both these events. That is why you see here A intersection B, and the denominator is what has already occurred. So B has already occurred, so that's why there is probability of B there. Now when we cross multiply, you realize that A intersection B is equal to probability of B multiplied by probability of A given B, as you can see it here. So still here what you should realize is that this probability is what has already occurred. So if here it is B, here it will also be B. If here it was A, here it will also be A, as we are going to see in the next line. So for the next line we are given probability of B given A. So in this case the numerator will still be the intersection of these two events, which is that, like I said, whether you say B intersection A or A intersection B, they mean the same. That's the numerator. Then the denominator is what has already occurred. So in this case A is what has already occurred, so that's why you put it at the denominator. Now when we cross multiply, you realize that A intersection B is equal to probability of A multiplied by probability of B given A. So like I said in the first line, what is here is what has already occurred. I think we realize that here there is A, here there is also A, and here there is B, here there is also B. So that is what you should remember from Bayes' theorem. So what does that mean? It means that these two expressions can be equated. So you shall come here and say that probability of A intersection B is equal to probability of A given B multiplied by probability of B, which is that, and is also equal to probability of B given A multiplied by probability of A, which is that. And that is what so this is what we call Bayes' theorem. We shall see how we can use it to answer the questions. So similarly, the formula also works for complements. For example, what you should remember is that you must be consistent. For example, in here it is A intersection B complement, meaning that now B is complement. That's why here, if we put here probability of B complement, here we must put probability of B complement, which has already occurred, and here it is that. So still here, if you put probability of A, it means that probability of A is one which has already occurred. That's why here it is B complement given A. Then for this one, if we put here probability of B, it means that B has already occurred. That's why we put it here. And in this case, if we put A complement, it means that A complement has already occurred. That's why we put it here. And lastly, this is also the same: B complement, B complement, A complement, A complement. So that is what you need to remember for Bayes' theorem, that what has already occurred is put here, and what has not, and what we want is what we put there. So now that we have mastered these formulae, we shall now see how we can use them to answer the question. So the first question came from UNEB 2019 of paper 2, question 13, and says two events A and B are such that probability of B is equal to 1/8, probability of A intersection B is 1/10, and probability of B given A, so this is the conditional probability, probability of B given that A has already occurred is equal to 1/3. So determine part A, the probability of A, part B, the probability of A union B, part C, probability of A given B complement has already occurred. So we shall start with part A. So part A, we know that if I want to get probability of A, I'll start from this. This is the Bayes' theorem, that if I'm given A intersection B and I'm also given B given A, it means that A has already occurred. That's why you put it here. Remember that rule. What has already occurred is what we put this side. So because here it is A which has already occurred, that's why you put it here, followed by the conditional probability. The next we shall substitute, because we know that probability of A is what we want. Then probability of A intersection B is 1/10. Probability of B given A is 1/3. So next is to make probability of A the subject, and when we make it the subject, we shall just cross multiply, take this one this side to come up with 3/10. So basically that's what they wanted for part A. Now before we go to the next slide, let's see how marks can be awarded. So B1 for you to code the definition for conditional probability correctly, M1 for substitution, and A1 for output. So that was part A. Now we shall go to part B, where they want probability of A union B. So we know that this is the formula. I think we remember from additional law in the previous video, we saw that probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So now in this case, we have got probability of A, and we know probability of B, and we also know probability of A intersection B. So we are going to substitute those probabilities. So when I substitute, I'll come up with probability of A, which is that which I've got, probability of A B is that, probability of A intersection B is that. So when I use the calculator, I'll come up with 13/40, and can be simplified as 0.325. So that was part B. Now part C, they want the probability of A given B complement has already occurred. So you have to remember the definition for conditional probability is equal to the intersection over what has already occurred. So in this case, intersection of these two is this one, which is A intersection B, so it becomes A intersection B complement and becomes the numerator. Then the denominator is what has already occurred. That's why you see here B complements, because here B complement has already occurred. Then from set theory, I think we remember that probability of A intersection B complement is equal to probability of A minus probability of A intersection B. So this was already covered in the first video, that is video 1. So it is better you go through it before you go to this video. Then probability of B complement, we also saw that is equal to 1 minus probability of B. So the good thing is that we know probability of A, We know probability of A, which is that, probability of A intersection B, which is that, and probability of B, which is that. So what you are going to do, you are going to substitute. So when I substitute, probability of A is 1 over 3, 1 over 3 over 10. Probability of A intersection B is 1 over 10, and probability 1 minus probability of B, which is 1 over 8. So next is to use the calculator. So when I simplify, this will come up with 2 over 10, and this I'll come up with 7 over 8. Now when I divide these two, I'll come up with 8 over 35. So basically that's what they wanted, and now let's see how marks can be awarded. So yeah, B1 for the definition of addition law, and M1 for substitution, and A1 for output. Then yeah, M1 for the numerator, this numerator, another M1 for this denominator, another M1 for division. Then B1 for simplifying numerator and denominator and output. So simplifying this to get this gives you this B1. Simplifying this to get this gives you that B1, and this output is what gives you this A1. So that was question 1. Now we shall go to question 2. So question 2 came from UNEB 2018 paper 2 question 2, and it says that two events A and B are such that probability of A given B is equal to 2 over 5, and probability of B is equal to 1 over 4, and probability of A is equal to 1 over 5. Find part A, probability of A intersection B, and part B, probability of A union B. So you start with part A, where they want probability of A intersection B. So what we know, the good thing is that we know that we know the probability of A given B, and this means that B has already occurred, and since we have probability of B, we can come and get probability of A intersection B from probability of B multiplied by probability of A given B. So always remember, what has already occurred is what we put here. Now probability of B was 1 over 4, so we shall put it there. Probability of B given A is 2 over 5, we shall put it there. Now when I multiply, I'll come up with 1 over 10 as my probability of A intersection B. So now that I've got probability of A intersection B, I can go ahead and get part B, which is probability of A union B. So I remember from addition law, probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. So I'll come and substitute. Probability of A is that, probability of B is that, and probability of A intersection B is that. Now when I simplify this, I'll come up with 7 over 10 as my probability of A union B. So basically that's what they wanted, and now let's see how marks can be awarded. So M1 for this and A1 for the output, B1 for the correct definition of the addition law, M1 for substitution, and A1 for output. So that was question 2. Now we shall go to question 3. So question 3 came from UNEB 2014 paper 2 question 9b, and it says events A and B are such that probability of A is equal to 4 over 7, probability of A intersection B complement is equal to 1 over 3, and probability of A given B is equal to 5 over 14. Find Roman 1 probability of B and Roman 2 probability of A complement intersection B complement. So just start with Roman 1. We shall say that probability of A intersection B is equal to probability of A minus probability of A intersection B complement. So I'm getting this because I'm given this conditional probability, and for this conditional probability it means that when I expand it, the numerator will be A intersection B over probability of B, and they want probability of B. So for me to substitute this into this, I'll have to first get probability of A intersection B, then I use Bayes' theorem. So this one from set theory, which was already covered in video 1, is equal to probability of A minus probability of A intersection B complement. So maybe as a reminder, what is here will not change. For example, if you look at this is A and this is A, it has not changed, so that's why you put it here. And this is B complement, so it has changed, that's why you don't put it there. So what doesn't change is what we put here. But more explanation can be found in video 1. So next we'll be substituting. So probability of A is 4/7 and probability of A intersection B complement is 1/3. So when I subtract, I'll come up with 5/21. So now that I've got probability of A intersection B, I can come and say that from Bayes' theorem, probability of B multiplied by probability of A given B is equal to probability of A intersection B. So I think you realize that what has already occurred is what we put here. So always remember that and don't interchange. So if you put here probability of A, that will not be okay because A has not yet occurred. Therefore, now that I've quoted this formula for Bayes' theorem, I can come and substitute. So B is what I want. Probability of A given B is 5/14, which is here. And probability of A intersection B is 5/21, which was already got there. So next is to make B the subject. When I make B the subject, I'll come up with 2/3. So that was Roman 1. Now we shall go to Roman 2. Roman 2, they want probability of A complement intersection B complement. So still from set theory, A complement intersection B complement is equal to probability of B complement minus probability of A intersection B complement. So like I said, what does not change is what we put at this point. For example, if you look at this expression, here it is A complement, here it is A, so A has changed, that's why you don't put it there. But if you look at B complement, here there is B complement and here there is also B complement, that is why you put B complement here. So more explanation can be found in video 1. So next is to substitute. B complement is equal to 1 minus probability of B. So probability of B is 2/3, that's why I put it there. So that is our B complement. Then A intersection B complement, it was already given here, so we shall come and put it there. Now when you simplify, 1 minus 2/3 is 1/3, and this is also 1/3, so in the end you shall come up with 0. So basically that's what they wanted, and now let's see how marks can be awarded. So this B1 for the definition using set theory, and M1 for substitution, A1 for getting A intersection B. Then B1 for this definition, M1 for substitution, and A1 for getting probability of B. Then here M1 for substitution and A1 for output. So that was question 3. Now we shall go to question 4. So question 4 says, question 4 came from UNEB 2013 paper 2 question 4, and it says events A and B are such that probability of A intersection B is 1/12 and probability of A given B is 1/3. Find probability of B intersection A complement. So first of all, from Bayes' theorem, remember we are given A given B, so we shall come and first quote Bayes' theorem. Because B has already occurred, that's why I put B here and decided to be the intersection. So when you substitute, you realize that B is not given, but we are given this conditional probability, which is 1/3, and this intersection is also 1/12. So from there we can get probability of B, and probability of B will be equal to 1/4. So now that I've got probability of B, I can use set theory and come up with an expression that probability of B intersection A complement is equal to probability of B minus probability of A intersection B. So the reason why you put here B is because B does not change in these two intersections. But when you look at A changes, so we can't put it here. So what we put here is what doesn't change. So More of the explanation will be found in video 1. Now we shall substitute. Probability of B is that, and probability of A intersection B is that. So when I subtract, I'll come up with 1/6 as my answer. So basically that's what they wanted, and now let's see how marks can be awarded. So M1 for this substitution, B1 for this output, B1 for this definition, then M1 for the substitution, and A1 for the output. So that was question 4. Now we shall go to question 5. So question 5 came from UNEB 2003, paper 2, question 1, and it says events A and B are such that probability of A is equal to 1/2, probability of B is equal to 8/3, and probability of A given B is 7/12. Find Roman 1 probability of A intersection B, and Roman 2 probability of B given a complement has occurred. So we shall start with Roman 1. So for Roman 1 we shall say from Bayes' theorem, probability of A intersection B is equal to probability of B multiplied by probability of A given B. So I think we realize that what has already occurred is what we put here, so always remember that. Now next is to substitute. Probability of B is here and probability of A given B is there. So when I multiply, I'll come up with 7/32. So now we shall go to Roman 2. So Roman 2, the one probability of B given a complement. So when we expand that, we shall come up with numerator will be the intersection of these two. That's why there is here A complement intersection B, and denominator is what has already occurred, which that's why you see here a complement. Then from set theory, you realize that this probability of A complement intersection B is equal to probability of B minus probability of A intersection B. Now why do we put B here? It is because if you look at these two intersections, A changes but B remains constant. So what remains constant is what we put here. Also still from set theory, probability of A complement is equal to 1 minus probability of A. So next we shall substitute. So in substitute, probability of B is 3/8. Probability of A intersection B we have got as 7/32. 1 is there, and probability of A is 1/2. So next is simplify. The whole of this bracket is equal to 5/32. Then this bracket is 1/2. So when I change this division sign to multiplication sign, I have to get the reciprocal. So the reciprocal of 1/2 is 2. That is why there is 2 there. So when I simplify this, I'll come up with 5/16. So basically that's what they wanted, and now let's see how marks can be awarded. So M1 for substitution and A1 for output. So this one was not supposed to be there. So B1 for the value of A intersection B, A complement intersection B. So getting this one alone will be a B1, because some students can decide to first calculate for A complement intersection B alone. So that is B1. Then M1 for dividing the two, and A1 for the output. So that brings us the end of this video. Thank you for watching, and be reminded that the next video will now be on independent events. So this one has been on dependent events, so the next video will be on independent events. So if you're not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video on independent events has been uploaded. And also, if you know of any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp, so that we can all benefit as a family.